Good afternoon, everyone. My name is Yu Xiao. I come from Wuhan University, one of the most beautiful universities in China. Today, we will talk about a referenced Hungarian algorithm for test allocation in global software development. This is a joint work with Wu Man, Jia Xiangyang, and Liu Ye. First of all, let's talk about the motivation about our work. The allocation of software development tasks is a critical management activity in distributed development projects. One of the most important problems is to find the lowest cost way to assign tasks in global software development, which can be solved by Hungarian algorithm. However, the original Hungarian algorithm only assumes that a task can only be solved by one development site. The assumption is not agreed with the actual case, where software development tasks is usually be solved through a collaboration among several sites. To address such an issue, this paper proposes a referenced Hungarian algorithm (RHA) for task assignment in global software development. Then we will talk about the existing approaches about the task allocation in global software development. The original Hungarian algorithm only assumes that the number of tasks is equal to the number of sets, and a task can only be solved by one development site. The usual assignment problem is defined as follows: assign n tasks to n development sites with the least total cost. Theorem 1. If a number is added to or subtracted from all of the entries of any row or column of a custom matrix, then the optimal assignment for the resulting cost matrix is also an optimal assignment for the original cost matrix. Here is a proof to certify Theorem 1. In practice, one of the most important problems is to find the lowest cost way to assign tasks in global software development, which usually be solved by Hungarian algorithm. Here is the process of the Hungarian algorithm. Here, we use an example to explain the Hungarian algorithm. A software development project consists of 4 different tasks: Task 1, Task 2, Task 3, and Task 4. There are 4 development sites: Site 1, Site 2, Site 3, and Site 4. They each demand different pay for various tasks, and our problem is to find the lowest cost way to assign the tasks. Step 1. Subtract 4.8 from row 1, 6.4 from row 2, 6.6 from row 3, and 5 from row 4. The resulting matrix is as follows. Step 2. Subtract 1 from column 4. The resulting matrix is as follows. Step 3. Cover all the zeros of the matrix with the minimum number of horizontal or vertical lengths. Step 4. Since the minimum number of lengths is less than 4, we have to proceed to Step 5. Step 5. Note that 1.4 is the smallest entry not covered by any line. Subtract 1.4 from each uncovered row. The resulting matrix is as follows. Now add 1.4 to each covered column. The resulting matrix is as follows. Now return to Step 3. Step 3. Cover all the zeros of the matrix with the minimum number of horizontal or vertical lengths. Step 4. Since the minimum number of lengths is 4, an optimal assignment of zeros is possible and we are finished. Since the total cost for this assignment is 0. It must be optimal assignment. Here is the same assignment made to the original cost matrix. So, we should assign test 1 to set 2, test 2 to set 4, test 3 to set 1, and task 4 to set 3. So, I will begin to introduce our approach. We first give the problem definition, then we present our RHA method for test allocation in global software development. The original Hungarian algorithm only assumes that the number of tasks is equal to the number of sites, and the task can only be solved by one development site. The assumption is not agreed with the actual case in global software development, where the number of tasks and the number of sites are not equal in general, and a software development task is usually be solved through a collaboration among several sites. Theorem 2. If a n multiplied by n matrix is transformed into 2n multiplied by n matrix by adding virtual sets with the 0 entries, then an optimal assignment for the resulting custom matrices is also an optimal assignment for the original custom matrix. Here is a proof to satisfy theorem 2. RHA approach found an optimal assignment according to a given n multiplied by n custom matrix. Algorithm 1 presents the procedure code of our proposed RHA method. We first subtract the smallest entry in each row from all the entries of each row, and then we subtract the smallest entry in each column from all the entries of each column. In this moment, each row and each column has at least one zero in the cost matrix. Next, we transform n multiplied by m matrix into 2n multiplied by n matrix by adding virtual sets with the 0 entries. We perform the original Hungarian algorithm on the new cost matrix to find the optimum test assignment. After that, we remove the virtual development sets and get the optimal assignment result. Now, let's see an example to know more about the RHA approach. A software development project consists of 4 different tasks: Test 1, Test 2, Test 3, and Test 4. There are 6 development sites: Site 1, Site 2, Site 3, Site 4, Site 5, and Site 6. They each demand different pay for various tasks. The problem is to find the lowest cost way to assign the tasks. There is a 6 multiplied by 8 cost matrix. Step 1. Subtract 4.8 from row 1, 6.4 from row 2, 6.6 from row 3, and 5 from row 4. The resulting matrix is as follows. Step 2. Subtract 1 from column 4 and 1.4 from column 5. The resulting matrix is as follows. Step 3. Transform 6 multiplied by 4 matrix into 2 4 multiplied by 4 matrix by adding 2 virtual sets with the 0 entries. The resulting matrix are as follows. Step 4. Performs the original Hungarian algorithm on the 2 4 multiplied by 4 cost matrix. The assignment result of the first cost matrix is as follows. Test 1 to set 2, Test 2 to set 4, Test 3 to set 1, and Test 4 to set 3. The assignment result of the second cost matrix is as follows. Test 1 to set 7, Task 2 to set 8, Test 3 to set 6, and Test 4 to set 5. Step 5. Remove the 2 virtual development sets and output the final assignment result. Then, we will detail our experiments. In the experiment, we employ one commonly used performance measure, SAR. It is defined and summarized as follows. As we can see in Figure 1, the SAR of the expansion matrix method goes up when the number of development sites increases. It shows that RHA can effectively allocate tasks to development sites with the lowest cost when the number of development sites changes. As we can see in Figure 2, the SAR of the expansion matrix method decreases when the number of tasks increases. It shows that RHA can effectively allocate tasks to development sites with the lowest cost when the number of tasks changes. Finally, we will give our conclusions and talk about the future work. In conclusion, we find that the algorithm RHA solves the problem that the project manager allocates n tasks to m sites at the least total cost by performing all operations on an n multiplied by m matrix. The proposed algorithm can effectively allocate tasks to development sites with the lowest cost. In the future, we would like to validate the generalization ability of our method on available real-world datasets. In addition, we plan to investigate the task assignment method based on social data. Thank you for your listening. That's all.